In music, the term note has two primary meanings: a sign used in musical notation to represent the relative duration and pitch of a sound. A pitched sound itself. Notes are the atoms of much Western music, discretizations of musical phenomena that facilitate performance, comprehension, and analysis. The term note can be used in both generic and specific senses. One might say either the piece "Happy Birthday to You" begins with two notes having the same pitch, or the piece begins with two repetitions of the same note. In the former case, one uses note to refer to a specific musical event. In the latter, one uses the term to refer to a class of events sharing the same pitch. Two notes with fundamental frequencies in a ratio equal to any power of 2 are perceived as very similar. Because of that, all notes with these kinds of relations can be grouped under the same pitch class. In traditional music theory within the English-speaking and Dutch-speaking world, pitch classes are typically represented by the first 7 letters of the Latin alphabet. A few European countries, including Germany, adopt an almost identical notation, in which H is substituted for B. However, most other countries in the world use the naming convention do re mi fa sol la si, including for instance Italy, Spain, France, Romania, most Latin American countries, Greece, Bulgaria, Turkey, Russia, and all the Arabic-speaking or Persian-speaking countries. The 8th note, or octave, is given the same name as the first, but had double its frequency. The name octave is also used to indicate the span between a note and another with double frequency. To differentiate two notes that have the same pitch class but fall into different octaves, the system of scientific pitch notation combines a letter name with an Arabic numeral designating a specific octave. For example, the now standard tuning pitch for most Western music, 440 Hz, is named or euro squared or A4. There are two formal systems to define each note and octave, the Helmholtz pitch notation and the scientific pitch notation. Accidentals, letter names are modified by the accidentals. A sharp unregistered trademark raises a note by a semitone or half step, and a flat unregistered trademark lowers it by the same amount. In modern tuning, a half step has a frequency ratio of approximately 1.059. The accidentals are written after the note name, so, for example, fa unregistered trademark represents F sharp, ba unregistered trademark is B flat. Additional accidentals are the double sharp, raising the frequency by 2 semitones, and double flat, lowering it by that amount. In musical notation, accidentals are placed before the note symbols. Systematic alterations to the 7-lettered pitches in the scale can be indicated by placing the symbols in the key signature, which then apply implicitly to all occurrences of corresponding notes. Explicitly noted accidentals can be used to override this effect for the remainder of a bar. A special accidental, the natural symbol unregistered trademark registered trademark, is used to indicate an unmodified pitch. Effects of key signature and local accidentals do not cumulate. If the key signature indicates G sharp, a local flat before a G makes it G flat, though often this type of rare accidental is expressed as a natural, followed by a flat to make this clear. Likewise, a double sharp sign on a key signature with a single sharp unregistered trademark indicates only a double sharp, not a triple sharp. Assuming inharmonicity, many accidentals will create equivalences between pitches that are written differently. For instance, raising the note B to bar unregistered trademark is equal to the note C. Assuming all such equivalences, the complete chromatic scale adds 5 additional pitch classes to the original 7-lettered notes for a total of 12, each separated by a half step. Notes that belong to the diatonic scale relevant in the context are sometimes called diatonic notes. Notes that do not meet that criterion are then sometimes called chromatic notes. Another style of notation, rarely used in English, uses the suffixes to indicate a sharp and is for a flat, for example fis for fa unregistered trademark, jis for ga unregistered trademark, is for a unregistered trademark. This system first arose in Germany and is used in almost all European countries whose main language is not English, Greek, or a Romance language. In most countries using these suffixes, the letter H is used to represent what is B natural in English, the letter B is used instead of bar in registered trademark, and hisses is used instead of B. Dutch speakers in Belgium and the Netherlands use the same suffixes, but applied throughout to the notes A to G, so that B, bar in registered trademark and B have the same meaning as in English, although they are called B, Bs, and BCs instead of B, B flat and B double flat. Denmark also uses H, but uses Bs instead of hisses for B. 12-tone chromatic scale. The following chart lists the names used in different countries for the 12 notes of a chromatic scale built on C. The corresponding symbols are shown within parentheses. Differences between German and English notation are highlighted in bold typeface. Although the English and Dutch names are different, the corresponding symbols are identical. Note designation in accordance with octave name. The table of each octave and the frequencies for every note of pitch class A is shown below. The traditional system centers on the great octave and small octave. Lower octaves are named contra, higher ones lined. Another system suffixes a number. In this system A4 is nowadays standardized to 440 Hz, lying in the octave containing notes from C4 to B4. The lowest note on most pianos is A0, the highest C8. The MIDI system for electronic musical instruments and computers uses a straight count starting with note 0 for C1 at 8.1758 Hz up to note 127 for G9 at 12,544 Hz. Written notes. A written note can also have a note value, a code that determines the note's relative duration. In order of halving duration, we have double note, whole note, half note, quarter note, eighth note, 16th note. Smaller still are the 32nd note, 64th note, and 128th note or 1, 2 note, 1, 4 note, 1, 8 note, 1, 16 note, 1, 32 note, 1, 64 note, and 1, 128 note. When notes are written out in a score, each note is assigned a specific vertical position on a staff position on the staff, as determined by the clef. Each line or space is assigned a note name. These names are memorized by musicians and allow them to know at a glance the proper pitch to play on their instruments for each note head marked on the page. The staff above shows the notes C, D, E, F, G, A, B, C A listed and then in reverse order, with no key signature or accidentals. Note frequency. In all technicality, music can be composed of notes at any arbitrary physical frequency. Since the physical causes of music are vibrations of mechanical systems, they are often measured in hertz, with 1 Hz equals 1 vibration per second. For historical and other reasons, especially in Western music, only 12 notes of fixed frequencies are used. These fixed frequencies are mathematically related to each other, and are defined around the central note, A4. The current standard pitch, or modern concert pitch for this note is 440 Hz, although this varies in actual practice. The note naming convention specifies a letter, any accidentals, and an octave number. Any note is an integer of half steps away from middle A. Let this distance be denoted n. If the note is above A4, then n is positive. If it is below A4, then n is negative. The frequency of the note is then. For example, one can find the frequency of C5, the first C above A4. There are 3 half steps between A4 and C5, and the note is above A4, so n equals +3. The note's frequency is. To find the frequency of a note below A4, the value of n is negative. For example, the F below A4 is F4. There are 4 half steps, and the note is below A4, so n equals A4. The note's frequency is. Finally, it can be seen from this formula that octaves automatically yield powers of 2 times the original frequency, since n is therefore a multiple of 12. And so the formula reduces to yielding a factor of 2. In fact, this is the means by which this formula is derived, combined with the notion of equally spaced intervals. The distance of an equally tempered semitone is divided into 100 cents. so 1200 cents are equal to 1 octave, a frequency ratio of 2 to 1. This means that a cent is precisely equal to the 1200th root of 2, which is approximately 1.000578. For use with the MIDI standard, a frequency mapping is defined by where P is the MIDI note number. And in the opposite direction, to obtain the frequency from a MIDI note P, the formula is defined as for notes in an A440 equal temperament, this formula delivers the standard MIDI note number. Any other frequencies fill the space between the whole numbers evenly. This allows MIDI instruments to be tuned very accurately in any micro-tuning scale, including non-Western traditional tunings. History of note names. Music notation systems have used letters of the alphabet for centuries. The 6th century philosopher Boethius is known to have used the first 14 letters of the classical Latin alphabet, A B C D E F G H I K L M N O, to signify the notes of the 2-octave range that was in use at the time, and which in modern scientific pitch notation is represented as A2 B2 C3 D3 E3 F3 G3 A3 B3 C4 D4 E4 F4 G4. Though it is not known whether this was his devising or common usage at the time, this is nonetheless called Boethian notation. Although Boethius is the first author which is known to have used this nomenclature in the literature, the above-mentioned 2-octave range was already known 5 centuries before by Ptolemy, who called it the perfect system, or complete system, as opposed to other systems of notes of smaller range, which did not contain all the possible species of octave. Following this, the range of used notes was extended to 3 octaves, and the system of repeating letters A G in each octave was introduced, these being written as lowercase for the 2nd octave and double lowercase letters for the 3rd. When the range was extended down by 1 note, to a G, that note was denoted using the Greek G, gamma. The remaining 5 notes of the chromatic scale were added gradually. The first being bar in registered trademark, since B was flattened in certain modes to avoid the dissonant tritone interval. This change was not always shown in notation, but when written, bar in registered trademark was written as a Latin, round B, and bar in registered trademark a Gothic or hard-edged B. These evolved into the modern flat and natural symbols respectively. The sharp symbol arose from a barred B, called the cancelled B. In parts of Europe, including Germany, the Czech Republic, Slovakia, Poland, Hungary, Norway, Denmark, Serbia, Croatia, Finland, Iceland and Sweden, the Gothic B transformed into the letter H. Therefore, in German music notation, H is used in lieu of bar in registered trademark, and B in lieu of bar in registered trademark. Occasionally, music written in German for international use will use H for B natural and BB for B flat. Since a B's or bar in registered trademark in Northern Europe is both rare and unorthodox, it is generally clear what this notation means. In Italian, Portuguese, Spanish, French, Romanian, Greek, Russian, Mongolian, Flemish, Persian, Arabic, Hebrew, Bulgarian and Turkish notation, the notes of scales are given in terms of do re mi fa sol la si rather than C D E F G A B. These names follow the original names reputedly given by Guido Drezzo, who had taken them from the first syllables of the first 6 musical phrases of a Gregorian chant melody ut quiant laxis, which began on the appropriate scale degrees. These became the basis of the solfege system. Do later replaced the original ut for ease of singing, though ut is still used in some places. C, or T was added as the 7th degree. The use of C versus T varies regionally. The 2 notation systems most commonly used nowadays are the Helmholtz pitch notation system and the scientific pitch notation system. As shown in the table above, they both include several octaves, each starting from C rather than A. The reason is that the most commonly used scale in Western music is the major scale, and the sequence C D E F G A B is the simplest example of a major scale. Indeed, it is the only major scale which can be obtained using natural notes, and typically the first musical scale taught in music schools. In a newly developed system, primarily in use in the United States, notes of scales become independent to the music notation. In this system the natural symbols C D E F G A B refer to the absolute notes, while the names do re mi fa sol la ti are relativized and show only the relationship between pitches, where do is the name of the bass pitch of the scale, re is the name of the second pitch, etc. The idea of so-called movable do, originally suggested by John Curran in the 19th century, was fully developed and evolved into a whole educational system by Zoltar N. Kodaly in the middle of the 20th century, which system is known as the Kodaly Method or Kodaly concept. See also, music and mathematics, diatonic and chromatic, ghost note, grace note, interval, money note, musical temperament, musical tone, note value, pensato, piano key frequencies, solfege, universal key, references, Nattiers 1990, pages 81-N9, ABs equals sharp. Is and S equals flat, Decis equals sharp. Bemol equals flat, Decis equals sharp. Hyphasis equals flat, A equals unregistered trademark. A currency equals unregistered trademark Boethius. D. Institution Musica. Book 4, Chap. 14. ed. Friedlein, 341. Bibliography, Nattiers, Jean-Jacques. Music and Discourse, Toward a Semiology of Music. Translated by Carolyn Abate. ISBN 0-691-02714-5. External links, Converter, frequencies to note name, +/sense, note names, keyboard positions, frequencies and MIDI numbers, music notation systems of frequencies of equal temperament tuning, the English and American system versus the German system, frequencies of musical notes.